Hello friends, I am Partharthi Virda and welcome to Quality Excellence Hub channel. If you are the first time visitor, then please subscribe to my channel. You can click on the bell icon so that you will receive notifications of my future video uploads. You can like my videos, you can comment on my videos, and you can share the link of my channel as well as videos to your groups and friends, so that they will also get advantage to join our family and enhance their knowledge. Today we are going to discuss about interpretation of control chart, which is a part of SPC, that is statistical process control. Now let us know what is process control. For that we need to know what is process first. It is a set of interrelated or interacting activities which transforms inputs into outputs. And what are the examples? Some manufacturing processes: cutting, turning, drilling, painting, etc. And what is process control? It is evaluation of variation of a process over a period of time. So over a period of time, whatever the variation is there within the process, evaluation of that is known as process control. And basically it monitors stability of a process. If you want to know more about the variation, I have already posted a video on SPC. You can find here there will be a I card. You can click on that and it will divert you to my video of SPC. So basically process control monitors stability of a process. And here you can see one example. In a turning process, shaft diameter variation was within plus or minus 0.2 mm on 1st February 2019, which gradually increased to plus or minus 0.3 mm on 20th February 2019. So this is just an example of monitoring the variation and evaluating the variation. Now let us know what is statistical control and when a process is said to be in statistical control. A process is said to be in control or stable if it is in statistical control, and a process is in statistical control when all special causes of variation have been removed and only common cause variation is present or remaining. So if you want to better know what is special cause and common cause, you can refer my video of SPC. I'll post on the end screens, so you will get a link from there also. You can watch my video of SPC, so you'll better know what is common cause and what is special cause. So a process is said to be in control if it is repeatable, predictable, stable over a period of time, and variation present is due to only common cause. And how do we check whether the process is within control or not? We check it by plotting and interpreting control charts and observing the pattern in dataset. So let us know further about interpretation of control charts. For interpreting control chart, you need to plot the control chart first, and looking to the type of data, there are different types of control charts. So control chart is an effective tool to monitor the process. Control charts are used to determine whether a process is in statistical control or not. If there are no points beyond the control limits, no trends up, down, above or below the center line, and no patterns, the process is said to be in statistical control. This we will learn further during our further course of time in this video. But different two types of data, there are two types of different data, variable data and attribute data. and there are different charts related to that data. I have already posted a video on X bar R chart. I'll give a link over here in iCard, so you can redirect yourself and you can watch that video if you want. These are all different types of charts related to variable data, and these are related to attribute data. This is a typical control chart. All type of control chart will have upper control limit, then a target line, then lower control limit. There will be an x-axis and y-axis, as well as there will be the data plots. This, for average chart, this will be averages of subgroups, and this line is average of average. So this is a kind of typical control chart, how it looks like. Now let us start interpreting the control chart. Once we have plotted the control chart, if we will not interpret the control chart, we will not get the benefit of plotting the control chart. So let us interpret the control chart. Process is said to be out of control if one of the following condition exists. So we'll go through different conditions here, and if any of this condition exists, it means the process is out of control. So the first condition is one or more points fall outside the control limits. So you can see here, upper control limit, this point is outside upper control limit, and this point is below lower control limit. So this condition is out of control condition. Now, before moving further, let us bifurcate the control chart in sigma zones. You can see here, this is upper control limit, this is average, or you can say target line, or this is lower control limit. And here we have bifurcated this part in 3 zones and this part in 3 zones. Each zone is of 1 sigma or 1 standard deviation. So total it will be 3 standard deviation on this side and 3 standard deviation on this side. This is only for the better interpretation of control chart conditions. Now let us have second condition. 9 consecutive points are on one side of the average. This is the average line. You can see there are 9 data plots which are above the average line. It may be here also in the similar manner, it may be below the average line also. So any of this type of condition, either it is above or below, is considered as out of control condition. Now let us have a third condition. 6 consecutive points increasing or decreasing. You can see here this trend, if it moves further, it will go out of control. So this type of condition is considered as out of control conditions. 6 consecutive points either in increasing condition or in decreasing condition. If this situation is there, if this is present, then the process is out of control. 14 consecutive points alternate up or down. If there are 14 consecutive points which are up and down, then this condition is also considered as out of control conditions. Means total 14 points, one will be down, then up, then down. Likewise, if total there are 7 patterns like this, means 14 consecutive points like this, then this process is considered as out of control. Fifth one is 2 points out of 3 consecutive points are on the same side of average in zone A or beyond. So you can see here, this is zone C, B and A. Here this is C, B and A. So if we consider the condition 5 here, then 3 consecutive points are there. Out of these 3 consecutive points, these 2 points are in zone A or beyond, means these 2 points are in zone A. So this condition is considered as out of control condition. And the sixth point is 4 points out of 5 consecutive points are on the same side of average in zone B or beyond. So you can see here, out of these 5 points, these 4 points, 1, 2, 3 and 4, they are in zone B or beyond, and they are on one side of the average. So this condition is also considered as out of control condition. Seventh is 15 consecutive points within zone C, above or below the average. You can see here 15 consecutive points are either above or below the average and they are within zone C. We normally when we see, we consider that this process is very good, but as far as SPC is concerned, this condition is considered as out of control condition. And the eighth one is 8 points in a row in zone B or beyond. You can see here 8 points. This is in zone B, 2 points in zone B, then crossing the average, and here you can see again it is in zone B, this is in zone A, again crossed the average and towards upper control limit, this is in zone B, zone A. So if you see, there are total 8 points which are in zone B or beyond, whether it is on this side of the average or whether it is on this side of the average. So total 8 points in a row in zone B or beyond. If this is the situation, then the process is considered as out of control. Now what to do when the process is out of control? In case of any out of control condition observed in process, then action is to be taken on the process to remove special causes present in the system to make it stable, predictable and repeatable. So what we need to do is, we need to take some actions to improve the process and to make it stable, predictable and repeatable. So once a process is in statistical control, suppose if we consider now the process is in statistical control, then we should move towards process capability study. So without process being in statistical control, if we move to process capability study, then it will not give us the right picture. So basically, once the process is within statistical control, then and then only it is advisable to move towards process capability study. So today our agenda is to know process control and the interpretation of control chart. For process capability, we'll just go through it. It is the ability of the process to produce output that meets specification. Means in process control, control limits were in picture, and you can see here in process capability, specification or process specification is there in picture. So process control and process capability are different. Process control is the prerequisite of process capability study, and a process is said to be capable if nearly 100% of the output from the process is within the specification. So I am going to post a video, separate video, detailed video on process capability. So we'll not discuss much here on process capability. So just to understand, process control is a prerequisite for process capability study, and process control and process capability study should not be misunderstood as same. They are different, and process control is the prerequisite of process capability study. So friends, I hope you liked my video. If you have still not subscribed to my channel, then please subscribe. You can click on the bell icon so that you will receive notifications of my future video uploads. You can like, share and comment my videos, and you can share the link of my YouTube channel to your friends and group so that they will also get advantage to join our family and enhance their knowledge. Thank you.